Hello and welcome everyone, welcome back to my channel. In this video, we'll be covering yet another topic of artificial intelligence, that is depth limited search or DLS. So DLS is a type of uninformed search algorithm which is a variant of depth first search. Over here you can see it is a variation of the depth first search algorithm. If you don't know about depth first search, I have made a dedicated video for this. I will attach that link in the description. In short, we can say that depth limited search is depth first search with a depth limit. That's what is being explained on the third point of the slide. By limiting the search depth, DLS ensures that the search does not continue indefinitely in infinite or large search spaces. Alright, now let's understand this with the help of an example. So the example for depth limited search is very simple. DLS is nothing but depth first search plus a depth limit. Now suppose this is my goal node, right? Let me mark it as G. So let's see how DFS or depth first search will approach this problem. So DFS will start searching from this node, then this node, and it travels down the branch like this. After a particular branch ends, it would jump to its sub branch of the parent node. Now over here the scenario is this sub branch extends infinitely. So what will happen that the DFS algorithm might get trapped in this along this branch and may never return back. So that's how DFS works. Now let's talk about the solution of this problem, how this problem can be solved. So depth limited search suggests us a way that we should add a depth limit. Considering this level as 0, so over here I am putting a depth limit so that the search algorithm doesn't cross this barrier. So now let's understand how DLS works. Remember, we'll be only searching till depth 3, right? And this is our goal node. So that's how DLS will work. This is the root node. It will travel down a particular branch, and on reaching this branch, it will find that there is a limit. It won't be exploring further down the branch and jump to the sub branch. Again, it will find a limit. On exploring the stack, it would jump onto this branch, exploring these two nodes, stopping at the limit, then over here, then onto this branch, and on exploring this node, it would find that this is the goal node. So the search would stop over here. So that's how depth limited search works. Immediately one question should come into your mind that what if I am having my goal node over here? You can see it is falling outside our depth limit. So what will happen that the DLS algorithm will never find this goal node. So over here it is incomplete in nature if the goal node falls beyond the depth limit, and it is complete only when the goal node falls within the depth limit, right? So that's the working of DLS. Now moving on to the advantages of DLS. The first primary advantage of it is that it prevents infinite loops, which is a major drawback in depth first search, where the execution used to take an infinite branch and never return back, a condition known as getting stuck in infinite loop. Secondly, it is more memory efficient than BFS, breadth first search. Thirdly, we have its usefulness for large or infinite search spaces. As in DLS, we impose a certain limit on searching, therefore advantages in that respect. Right. Now this was all about the advantages. After advantages, let's discuss about the disadvantages. It may miss the solutions. Therefore, it is incomplete in general sense. But one problem with this sentence is that it doesn't present the full picture. There is a catch in it. That is the reason I have mentioned a note that DLS is complete only when the goal node exists within the defined depth limit. Suppose we are searching a goal node, and if it's outside our depth limit, if it's outside the depth limit of DLS, it won't be able to search it, which is obvious. So that's why I have mentioned a note over here. Now moving on to the second disadvantage, it is not optimal. Optimality basically refers to whether it will be able, if it finds a solution, will it be cheapest? So the answer is no. So that's why DLS is not an optimal search algorithm. Since now you have understood the working of DLS, now it won't be tough for you to understand this simple pseudocode of how this algorithm works. So over here I am having my DLS function which will be getting a node, a goal node and a depth limit. Meaning the function call statement would be having the current node, the goal node and the depth limit. So when this function would be called for the first time, this node would be the root node, right? So first of all, a condition would be checked if this current node equals to the goal node, and if this condition is true, it returns goal found. Otherwise, another condition is checked, which checks that if our depth limit has reached 0. If yes, it would be returning a string cutoff, meaning it has reached its depth limit. If both of these above conditions are false, then our else condition would get executed. This else condition would be having a for condition inside it, which will keep on iterating over this node to find the successor of the current node. As you can see over here, I'm trying to find the successors of a particular node and then assigning it to a variable child. Inside it, there is a result variable which would recursively call this DLS function. Now our current node would be the child node that we have found by finding the successor of this node. The goal would be the same and the depth limit would be decreased by 1. Since we are exploring this child of this node, it is obvious that that child would be one level below this node. That's why we are passing depth limit minus 1. So on the recursive call, again these two conditions would be checked. If node equals to goal, goal found. Otherwise, if depth limit reaches 0, then return cutoff. So this process will keep on happening recursively. And suppose if at any point this result variable gets assigned with this goal found string, from where this goal found string would be assigned from here. If result equals to goal found, then return result and the execution of this entire function stops. And if in case after exploring this entire search tree within the depth limit we never reach to this result and this loop terminates, what would happen? The function would return failure, meaning the goal node couldn't be found within the defined search limit. Alright, so this was the simple working of DLS. So first of all, thank you for watching the video. In the next video, we'll be studying about iterative deepening search. So make sure you subscribe to the channel and don't forget to hit the like button.